Hello everyone. I hope you are in good health and are preparing well for your board exams. Last time I came with exercise 9B of your chapter 9 matrices. Okay. Today I will be explaining you the concept of multiplication of matrices, and after this chapter I will be bringing you another presentation on exercise 9C. Okay children, which deals with multiplication of matrices. Okay, this chapter has been taken from Concise Mathematics Class 10 Selina edition 2024 by R.K. Bansal. Okay. Multiplicability of matrices means that whether the matrices are compatible for multiplication or not. Okay, so point number 9.13, that is, which is multiplicability of matrices. Compatibility of matrices for multiplication of matrices. Two matrices A and B can be multiplied together to get the product matrix AB if the number of columns in A, that is the left hand matrix, is equal to the number of rows in B, the right hand matrix. Means the first you have to consider, see that the number of columns in A, okay, the vertical columns, vertical ones, are equal to the number of rows, that is the horizontal lines in the product in the second matrix, that is matrix B. Okay. Let matrix A is equal to 3, 4, 5, 0 and matrix B is equal to 1, 2, 3, 4. Since the number of columns in A is equal to the number of rows in B, see the number of columns in A, that is 2, and the number of rows in B is also 2. Okay. So, see here children, there are 2 columns here and there are 2 rows here. Okay. So, product matrix AB is possible, and AB is equal to 3, 4, 5, 0 into 1, 2, 3, 4. Okay. Now step 1. What is the step 1 children? Step 1 says that multiply every element of first row with corresponding elements of first column. Okay. First row has to be multiplied by first column of matrix B and add them to get the first element of the first row of the product matrix AB. Okay, I'll explain it to you here. AB matrix is equal to 3, 4, 5, 0. So we will take the first row from here and first column from here. Okay, and we multiplied 3 by 1 and 4 by 3. Okay, first row, first number will be multiplied by 1 and second column will be multiplied by second row first number. Okay, so 3 into 1 plus 4 into 3, this will be multiplied like this. Okay, so what will we get after addition? 3 1 is 3 plus 4 3 is 12. We will get 15 as the answer. That is your first element. Okay, now coming to the step number 2, multiply every element of first row of matrix A with corresponding elements of second column. Now we have to consider the second column, okay, of B and add them to get the second element of the first row of the product matrix AB. Second element of the first row. First element of the first row you have found. Now you have to find the second element of the first row. So 3, 4 into 2, 4. Okay. 3 2 is 6 and 4 4 is 16. Therefore 3 2 is 6 plus 16. What is that? 6 plus 16 is equal to 22. So you got the next number in the first row, that is 22. Okay. See children, my matrix multiplication questions come in exams, so better be thorough with it, because it is if this topic, if they want to pick up question from this topic, they will definitely pick up one question from multiplication of matrices. Okay. In step 3, in the same way, multiply the elements of the second row of A with the corresponding elements of the first column of matrix B and get the first element of the second row of AB. Okay, first element of the second row of AB, that is this number. See how? Now we are taking the second row and multiplying it with the first column. Okay, so 5 ones are 5 plus 0 into 3 is 0. That is 5. 5 will be only the answer. That is 5 plus 0 is equal to 0. So here we are getting the third element and that is 5. Okay. Now finally what we do, multiply the elements of second row of matrix A with the corresponding elements of second column of B to get the second element of the second row of AB. Last element you have to find out, that is the second row, second element. Okay, now this was the first matrix and this is the second matrix, and you have to multiply the second row with the second column. 5 2s are 10 and 0 4s are 0, so 5 2s are 10. 10 plus 0 is equal to 10, so the last number will be 10. Therefore product of matrices A and B will be 15 22 5 and 10. Okay, and that will be the answer. Now product of matrices A and B in finding, while AB is equal to first row of A into first column of B, first row of A into second column of B, second element in the first row is second, in the second row the first element is second row of A into first column of B and second row of A into second column of B. Okay, this is what you have. When you practice this, then this you can learn this, but when you practice this, practice many sums, you don't have to learn this. Okay, it will be you will easily be able to solve the questions. If A is equal to minus 2 3 4 1 and B is equal to 1 2 3 5, okay, find 1 AB, second BA. Okay, now is AB is equal to, now the third part of the question is AB is equal to BA. Write the conclusion that you get. C, that write down the results obtained in 3. So solution, first AB is equal to minus 2 3 4 1 and 1 2 3 5 is the second matrix. Okay, now minus 2 into 1, 3 into plus 3 into 3 plus 3 into 3, minus 2 into 2 plus 3 into 5. Okay, that is only written here. 4 into 1 plus 1 into 3. Okay, and 4 into 2 plus 1 into 5, that will give you here 9 minus 2 is 7. Here 15 minus 4 is 11. 4 plus 3 is 7 again, and 8 plus 5 is 13. That is the answer. Now BA, matrix BA we have to find out. So 1 2 3 5, that is BA matrix is first, put first, and A matrix, that is minus 2 3 4 1 is put second. Okay, now 1 into first row will be multiplied with first column, therefore 1 into minus 2 plus 4 into 2. Okay, 1 into 3 plus 2 into 1, that will be the second element. 3 into minus 2 plus 5 into 4, this will be the third element, and 3 into 3 plus 5 into 1, that will be the fourth element. So what is 6 5 14 14. Okay, so AB is not is equal to BA, because what we got the answer in AB, it is not equal to BA. Therefore matrix multiplication is not commutative. Okay, what do you mean by commutative, children? That it is not in addition A plus B is equal to B plus A, but in matrix multiplication AB is not equal to BA. Okay, now coming to the solved question 9. Okay, let A is equal to minus 3 3, 2, minus 2, and B is equal to 4, 6, 4, 6. Find the matrix AB. Write the conclusion, if any, that you can draw from the result obtained. AB matrix will be minus 3, 3, 2, minus 2 into 4, 6, 4, 6. But you get the answer here as minus 3, first row into first column, minus 3 into 4, 12, and 12, and 3 4 are 12, minus 12 plus 12, minus 18 plus 18, then 8 minus 8, and 12 minus 12. So what do you get the matrix as? Null matrix, zero matrix. Therefore, the conclusion that can be drawn is that the product of two non-zero matrices can be a zero matrix. Okay, children. So coming to question number 10, children. If A is equal to 4 minus 3, 3, B is equal to 6, 5, 3, 0, and C is equal to 2, 3, minus 1, minus 2, show that AB is equal to AC. Write the conclusion, if any, that you can draw from the result obtained above. Okay. Now, AB is equal to means multiply A and B. It can be written as 4 minus 3, 3 into 6, 5, 3, 0. Okay. So when we multiply these two matrices, we get 24 minus 12, 20 plus 0, a minus 18 plus 9, and minus 15 plus 0, that is 12, 20 minus 9 and minus 15. Okay, AB value as this. Okay, 12, 20 minus 9 minus 15. Now, what is the value of AC? AC is equal to 4 minus 4 minus 3 minus 3 minus 3, 3 into the C matrix. Okay, and what we get the answer as 12, 20 minus 9 minus 15. Therefore, AB is equal to AC. So the conclusion which we draw here is that AB is equal to AC, because it implies that matrices B and C are not equal and matrix A is not equal to 0 matrix, even then AB is equal to AC. Okay, AB and AC can be equal only if means a condition can be there when A is a zero null matrix. Okay, so AB can be AC is equal to a null matrix. But here we see that we are multiplying two matrices and B and C are not equal. So A is not a null matrix. Now conversely, if AB is equal to AC, it does not imply that B is equal to C. That is, in AB is equal to, here it was written BC, children. So I have corrected it. I have written it AC. That is, if AB is equal to AC, we cannot cancel matrix A from both the sides. Okay, because in other words, B cannot be equal to C, because the cancellation law is not applicable in matrix multiplication. Okay, coming to point number 9.14 now. Okay, identity matrix for multiplication. In matrix multiplication, the unit matrix I is known as the identity matrix for multiplication. You know the unit matrix which contains only one at the diagonal places, at the diagonal, that is, which is the diagonal, diagonal is that which is drawn from the left hand corner to the right hand corner. Now, so if we use any unit matrix or identity matrix to multiply to a matrix, then the matrix remains unaltered. That is, if I is the unit matrix of the same order as A, then A into I is equal to I into A is equal to A. Therefore, let A is equal to 2, 3, 4 x. AI is equal to, if you multiply by 1, 0, 0, 1, that is 2, 3, 4, 6, it will give you the same answer as 2, 3, 4, 6, that is in matrix A. If I is multiplied from the left hand side, I, A, then also you will get the answer as 2 3 4 6, that is matrix A. Therefore A into I is equal to A is equal to I into A. Okay, if A is equal to 2 minus 1 minus 1 3, evaluate A square minus 3A plus 2I, whether I is a unit matrix of order 2, where I is a unit matrix of order 2. Okay, now the solution: a unit matrix of order 2 means a unit matrix of order 2 by 2. Okay, a unit matrix of order 2 means a unit matrix of order 2 by 2. Okay, now A square, first you have to find A square. A into A, that is 2 minus 1 minus 1 3, 2 minus 1 minus 1 3, which will give you the answer as 4 plus 1 minus 2 minus 3 minus 2 minus 3 minus plus 1 plus 9, that is 5 minus 5 minus 5 10. Okay, now we will do the A square minus 3A plus 2I, that is scalar multiplication. Okay, 5 minus 5 minus 5 10 minus 3 into 2 minus 1 minus 1 3 plus 2 into identity matrix, that is 1 0 0 1. So what we get the answer as 5. We add all the 3 because I have multiplied the second matrix by minus 3. Okay, so therefore outside the sign comes plus. Okay, so when we add all the 3 matrices, this minus 3 has been multiplied by 2 minus 1 minus 1 3. So what we get as the answer as 1 minus 2 and 3, that is the answer. So here is something important for mentioning, children, that if the order of a matrix A is m by n and the order of matrix B is n by p, then the product matrix AB is possible, that is matrices are conformable or compatible for multiplication. As you can see that the number of columns in B, number of columns in B is, that is n, is equal to number of rows in number of columns in A is equal to the number of rows in B, right? Number of columns of matrix A are equal to the number of rows of the second matrix B. Therefore these two matrices are compatible for multiplication, and the order of the matrix C obtained is m by p, that is m rows and p columns. M rows taken from A and p columns taken from B, that is the number of rows of first matrix into number of columns of second matrix. Okay, second matrix B. So it is written A m by n into p n into p is n by p is equal to C m by p. Okay, m, the rows are taken from the first matrix and the columns are taken from the second matrix. First one, A 3 by 5 into B 5 by 2 is equal to A 3 by 2 matrix order. We have to just find the order of these matrices. P 4 by 3 into Q 3 by 2 is equal to P 4 by 2, and so on. Also consider A 2 0 5 3 4 1 and B is equal to 1 by 3. And therefore A is a 3 by 2 matrix. Okay, and B is a 2 by 2 by 1 matrix. Yes, hence AB is possible because the number of columns is equal to the number of rows. The order of the matrix will be number of rows in A into number of columns in B. Number of rows in A was 3 and number of columns in B are 1, therefore 3 by 1. Okay, which is a 3 by 1 matrix. If A is equal to 3 5 4 minus 2 and B is equal to 2 4, the product AB, is the product AB possible? Give a reason. If yes, find AB. Solution: since the order of the matrix is 3 5, A is 3 5 4 2 2 by 2 and the order of matrix B is 2 by 1, Therefore, a product AB is possible as number of columns, number of rows in B is equal to number of columns in A. That is the condition. It is fulfilling the condition, and therefore when we find matrix AB, then we multiply when matrix AB, then we get the answer as 26 and 0. Okay, in one column. That is the answer. Now remember children, these are some important points which you should remember, because when you keep it in memory, you can solve some of the questions also, and also some you when there are some when you are in doubt, you can uh, get the answers from this. Okay, for any three matrices A, B and C which are compatible for multiplication, ABC is equal to ABC. Similarly, BAC is equal to BAC, that is, and CAB is equal to C into AB, and so on. Okay. For any three matrices A, B and C which are compatible for multiplication, A into BC is equal to A into BC. Similarly, BAC is equal to B into AC. Then C into AB, and so on. Okay, first you multiply the later matrices and then you multiply it with the form of first matrix. In general, AB is not equal to BA, that is, product of matrices is not commutative. AB into C is equal to A into BC. Okay, if you multiply the first two matrices and then multiply by C, it is same as multiplying the first matrix by the multiplication of the last two matrices. That is, product of matrices is associative. Okay, you can either multiply AB first and then C, or you can multiply BC first and then A. Okay, if A is not equal to 0 and AB is equal to AC. Okay, if A is not equal to 0 and AB is equal to AC, then it is not necessary that B is equal to C. Okay, we cannot apply the law of cancellation here and say that B is equal to C. Okay, if AB is equal to 0, A into B matrix is a null matrix, then it is not necessary that A is equal to 0 or B is equal to O, that is a 0, that is null matrix. Okay, if A is equal to 0 or B is equal to 0, AB is equal to 0 equal to BA. Okay, however, if A is equal to 0 or B is equal to 0 null matrix, AB will be equal to null matrix, or it will be equal to BA, same thing, because any one of the matrix being null matrix, they will give result will be only a null matrix. Now seventh, first part, A into B plus C is equal to AB plus AC, that is, in matrices, distribution over multiplication is distributive over addition. Therefore, A into B plus C is equal to AB plus AC. Now the second part, A plus B into C is equal to AC plus BC. Okay, in the same way, A into B minus C is equal to AB minus BC. If also the subtraction part, A into B minus C, A minus B into C is equal to AC minus BC. Okay, means whether it comes in the beginning or at the end, the distribution multiplication is distributive over addition or subtraction. Okay, now let A is equal to 3, 2, 0, 5 and B is equal to 1, 0, 1, 2. Okay, find A plus B into A minus B. Secondly, A square minus B square. Is A square minus B square equal to A plus B into A minus B? We know the rule of algebra that A square minus B square is equal to A plus B into A minus B. Let us check whether they both are equal or not. Okay. So the first course, in the first part, first we will find A plus B, that is 3205 plus 1012, we will get 4217. A minus B, we will do 3205 minus 1012, we will get 22 minus 13. Now a plus b into a minus b will give you 4, 2, 1, 7 and 2, 2 minus 1, 3. Therefore, which is equal to 8 minus 2, 8 plus 6, 2 minus 7, 2 plus 21 is equal to 6, 14 minus 5, 23. Now a square is equal to a into a, that is 3205 into 3205, and it will give you the answer as 916,025. Okay, so what we got as a plus b into a minus b, 6, 14 minus 5, 23. Now we are going to find out a square minus b square. Okay, b square is 1012 into 1012. 1012 into 1012 is giving you 1034. A square minus b square will give you 916,025 minus 1034. That is 816 minus 321. Clearly from 1 and 2 we see that a minus b into a plus b is not equal to a square minus b square. Okay, 14th question, given 3 minus 894 into xy is equal to minus 2 8, find x and y. This type of questions also come in your exam, children, where two matrices are given equal and you have to find out the variables. 3 minus 8, 9, 4 into xy is equal to minus 2 into 8. Okay, now you will do the same thing. 2 into 1 matrix, sorry, 2 into 2 into 2 into 1. So the resultant matrix is 2 into 1. So first we will multiply first row and first column, then second row and first column. So first row and first column we are getting 3x minus 8y, and first row and second column, second row and first column we are getting 9x plus 4y is equal to minus 2 and 8. 3x minus 8y is equal to minus 2. 9x plus 4y is equal to 8, and when you multiply it by 2 we get 18x plus 8y is equal to 16, and here from here you will get 3x minus 8y is equal to minus 2, and then we will cancel 8x and 8y and minus 8y, and here we will get 18x is equal to 16, 3x is equal to minus 2. Okay, 18x, so 18 plus 3, 21x, and 16 minus 2 is 14. X is equal to 14 by 21, that is 7 to the 14, 22 by 3. 2 by 3. See, 3x minus 8y is equal to minus 2. 3 into 2 by 3 minus 8y is equal to minus 2. 8y is equal to 4 and y is equal to half, and that is the answer. If B and C are two matrices such that B is equal to 1, 3, 2, 0 and C is equal to 17, 7, minus 4, minus 8, find the matrix M so that B M is equal to C. So we have to find a complete matrix here, okay, containing 4 elements, so that we can equate it with B, multiply it with by B and get the answer as C. Now see the solution, children. B M is equal to C, 1, 3, minus 2, 0. M is equal to 17, 7, minus 4, minus 8. Okay. Since M is compatible for multiplication with B, hence its order is equal to 2 by 2. Because at the end also we are getting a 2 by 2 matrix. Okay. So M should also have its order as 2 by 2. Suppose we assume that M has an order M by N, and B has order 2 by 2, C has order 2 by 2. So we know that the resultant matrix is of the order M into P. That is, 2 will come from B matrix, and P, that is N, will the column matrix P will come from matrix M, that is N. And here for the number of columns in B should be equal to the number of rows in A M. Therefore, M is equal to 2. Therefore, the matrix M into N, M by N is equal to 2 by 2. I hope you must have understood. N is equal to 2 because we know that M into N into P is equal to M into P. So P value is equal to the column value of n. Okay, and the row value will be equal to the column value of P. Now let matrix M is equal to A, B, C, D. Okay, given Bm is equal to C, we can say that it implies that 1 by 3 into minus 2 0 A, B, C, D is equal to 17 7 minus 4 minus 8. Now 1 3 minus 2 0 ABCD is equal to 77 minus 4 minus 8. You will calculate the, you can do the calculations. A plus 3C, B plus 3D minus 2A minus 2B is equal to 17 7 minus 4 minus 8. Therefore minus 2A is equal to minus 4, A is equal to 2, A plus 3C is equal to 17, C is equal to 5, 2B is equal to 8, B is equal to 4, B plus 3D is equal to 7. Therefore D is equal to 1. Therefore, the matrix is 2, 4, 5, 1. Now, children, coming to the 16th question, find the matrix M such that M into 3, 6, minus 2, minus 8 is equal to minus 2 by minus 2, 16. Let order of matrix M is equal to M into N. Okay. If M into N is the order of the matrix and 2 by 2 is the order of the second matrix, and what matrix we get, resultant matrix order will be is 1 by 2. Okay, it is given. So the N into, again we will take the number of rows in N, the number of columns in A, that is N, is equal to the number of rows, that is equal to 2, and M will be equal to 1 because M into N into N into P is equal to M into P. So M value will be equal to 1. So therefore the order of the matrix is equal to M is equal to 1 by 2. Let M is equal to A, B. Okay, the two elements of the matrices are A and B. Now AB is the matrix M is into 3, 6, minus 2, minus 8 is equal to minus 2, 16, 3A minus 2B, and 6A minus 8B is equal to minus 2, 16. 3A minus 2B is equal to minus 2. So this is the first matrix, first equation, and if you multiply this equation by 4, what we get, 12A minus 8B is equal to minus 8. Okay. And when we take the second equation, that is 6A minus 8B is equals to 16. Now we subtract the second equation, that is 6A minus 8B is equal to minus 16 from 12A minus 8B is equal to minus 8. Minus plus 8B will get cancelled. 12 minus 6A will be 6A is equal to minus 24. A is equal to minus 4. Okay. Now 3A minus 2B is equal to minus 2, 12 minus 2b is equal to 2, 2 minus 2b is equal to 10, therefore b is equal to minus 5. 10 divided by 2 is equal to minus 5. Therefore m is equal to minus 4 minus 5. The elements of m are minus 4 minus 5. Okay. State with reason. I think this is the last question, children. State with reason whether the following are true or false. A, B and C are matrices of the order 2 by 2. A into B is equal to B into A. Secondly, A into B into C is equal to AB into C. A plus B square is equal to A square plus 2AB plus B square. A into B plus C is equal to AB plus AC. Okay. Now first taking A into B is equal to B into A. We already know that the matrix multiplication is not commutative. Therefore, the first one is false. Okay. Therefore, AB is not equal to BA. Coming to the second part, A into B into C is equal to A into B bracket into C. This is true, children, because matrix multiplication is associative. Okay, this is true as matrix multiplication is associative. Now the third one was A square plus 2AB plus B square. Okay, so a plus b the whole square is equal to a square plus 2ab plus b square false, as laws of algebra are not applicable to matrices. Okay, now fourth one is again true, as in the case of matrices multiplication is always distributive over addition. A into b plus c is equal to ab plus ac. True, as in the case of matrices multiplication is always distributive over addition. Okay, so children, if you have not liked my video or subscribed, please do so. I need your support, I need your subscriptions for continuing my journey with you. Okay, from next time I will be giving you some questions also to solve and give me the answers. If you will give me the answers, then I will see how means how much you are prepared. Okay, from the this thing, how much you are prepared with the answers, with the topic. Okay, so let's end the session here, and please subscribe my channel's videos for children, and please go through the whole video. And before before doing the next exercise 9c, just go through the whole video and then do the exercise 9c and then check it from my presentation. Okay, so thank you children, thank you for viewing my presentation, and please children, I request you to subscribe my channel. And class 10th maths, this I will be bringing circles with for after completing matrices. Okay, so presently I have completed 9c also exercise, and I'll be giving you the presentation after some time. Okay, and then I will be giving you 9d also, might be, or some questions of 9d, and then I will be bringing circles. Okay, because there was a request from Sarvagya that he wants to have circles as to be taught. Okay, so children, please like and subscribe and share my channel, share my video with all the students who are studying in class 10th, so that they can also benefit from the videos. Okay, so thank you children, thank you once again, God bless you all, be happy always, bye bye.